welcome back to another Feeding Minds and Families Activity Kit tutorial. In this tutorial, we're going to be talking about the renewable energy activity that is found in our most recent winter activity kit. In this activity, you're going to be making 3 different renewable energy sources: a wind turbine, a solar panel, and a hydroelectric generator. At the end of this activity, you'll be able to compare and contrast these different energy sources to see what their possible benefits are and where some of their drawbacks might be, and how they might be used in a real-world application. At this point, we'll move forward and start with the first part of the activity, which will be making the wind turbine. To start off this activity, we're going to be making the wind turbine. We're going to be following the step-by-step instructions that are included in the guide that's in the booklet in the activity kit. So what we're going to do first here is we're going to take the 2 large wooden panels and slot them together like this. This will allow your wind turbine to stand upright. Now in my case in this video, I'm probably going to have it laying down so you can actually see the whole thing, but in your case you can leave it standing upright. Now the next step will be to take your breadboard and remove the adhesive backing off the back of it, and then to press it onto the taller panel like so. Now your breadboard might be a different color than what's shown here in the video or in the manual, but all of the colors work exactly the same, so it doesn't really matter for this activity. And once you have your breadboard attached, you're going to take a zip tie and place it through the 2 holes that are located on top of the tall piece here. Now what you want to do is create a loop that is on the same side as the breadboard, as you can see here. So the loop and the breadboard are on the same side of this piece of wood. Once you have that loop, you want to take your zip tie and attach the back end of it to the head of the zip tie here. And you'll hear it click into place. Now you don't want to tighten this all the way yet, so leave this loop fairly open, because we're going to use this loop to attach the motor to the head of this windmill. So once the loop is in place, you can take the small motor that is provided with the kit and place it through the loop here. So you want to make sure that the motor shaft is facing towards the inside of the windmill, and that the wires that are attached to it are facing down towards the wood. So you'll lay the motor in this loop here, and you'll notice the wires fit just beyond the edge of the wood here. And then you can tighten this loop down so that it attaches the motor to the kit. At this point, you can pull the zip tie tight. As tight as you can, you don't want this moving around too much. And once you have it in place, like shown here, you can take a pair of scissors and snip the remainder of the zip tie off. Now your motor's attached and ready to go to generate some power. So now what we want to do here is take the fan blades that are provided and attach them onto the shaft of the motor. So you want to hold the motor in place so that you don't push it off out of the zip tie, and you'll just press the fan blade onto the shaft. At this point, spinning these will spin the motor itself. Once you have your fan and the motor in place, we're going to take the 2 motor leads and attach them to the breadboard as shown in the manual. The manual will explain how breadboards work and how these attachments work inside of the breadboard. So we'll let you go look at that and explore how that works. But for the sake of simplicity here, you just want to make sure that these 2 cables are in 2 different rows of the breadboard. So in this case, we'll take the black lead and put it in the first row, and we'll take the red lead and we'll put it in the 3rd row. Now these leads are attached and ready to go to take some measurements. At this point, we'll move over to the multimeter, explain how that works a little bit, and then show how we're actually going to go about testing this. So now for this portion of the activity, you can actually take your wind turbine and set it off to the side for a moment as we go over the multimeter and its functions. You'll need the multimeter and the 2 probes that are provided. The activity manual will go over in a little bit more detail how these function and the different readings that they can take. But in our case, we're just going to be giving a quick introduction of how it works and what you're going to be needing for this activity itself. So the multimeter essentially is a tool that lets you take different electrical readings in a circuit. In our case, we're going to be measuring the current and the voltage using two different settings. DCA, which is your DC current, and DCV, which is your DC voltage. Voltage measured in volts and current measured in amps. In this case, these are going to be milliamps since we're much smaller than an actual amp of current. So your probes are actually what's going to be measuring the system. They're pretty much just alligator clips that grab onto different parts of the circuit. And the other side of them is just a banana plug, which goes into the multimeter and lets you take the readings. So in our case, we're going to be taking the black probe and plugging it into the COM port on the bottom. And then the red probe will be going into the middle port listed as voltage, ohms, and milliamps. And whenever you're taking a reading, you'll need to have the multimeter switch to the on position in order for it to take a reading. At this point, we'll start moving back over into the activity and going over how to take these readings. So now that your multimeter is set up, we'll take our wind turbine setup and bring it back and get ready to start taking readings from it. So in order to actually grab onto the circuit with the alligator clips on the probes, we're going to be taking the two jumper wires that are provided in the kit. You should have a red and a black one, and plugging them into the breadboard in the same row as the red and the black cables coming off of the motor. So in this case, I'm plugging the red wire into the same row as the red wire from the motor, and the black wire in the same row as the black wire from the motor. Now make sure this gets pressed all the way into the hole in the breadboard in order for it to actually make contact. Now you have these two jumper wires you can grab onto using the alligator clips from the multimeter. So at this point, you can take the black clip from the multimeter and clip it onto the end of this black wire here, making sure that you're grabbing the metal portion. And then the same thing with the red probe, grabbing onto the red portion of the wire here. Now your multimeter is hooked up to this circuit and you can take readings from it. So to actually take the readings from this activity, you're going to need to switch the multimeter into the on position. And to start, we're going to be taking our voltage reading. So you want to make sure that the dial is turned to the 20 in the DCV section. At this point, your circuit should be all hooked up, so your multimeter will read the outputs coming off of the generator. So as you spin the fan blades, you'll notice that this reading will increase. Right now it's just at 0 because nothing's actually happening. So what you can do is you can take your metal straw that's provided in the kit, or simply just blow on the fan or turn it by hand, and you'll see this number jump up. Now, as you do this, you want to try and get the highest reading that you can, and then record that reading in the table that's in the book. Once you get your voltage reading, you're going to take your multimeter and you're going to turn it to the 200M section in the DCA portion. At this point, we're going to be measuring the current output from this motor. You'll do the same thing as when you were measuring the voltage, blowing on the fan with the straw, or just blowing on it, or turning it by hand, and try and get the highest reading that you can. Once you get that number, take that and record it in the table in the book. At this point, you have the voltage and the current output from this wind turbine, and we can use that to calculate the power output towards the end of the activity. We'll now move on to the next portion of the activity, which will be the solar panel. To begin the solar panel testing, we'll start by disassembling the windmill just a little bit. All you want to do is take the probes off of your jumper cables that we added in, and then we'll take the wind turbine and set it off to the side. Now you're just going to need your multimeter and the provided solar panel in the kit. So the solar panel is going to look a little bit different than the one that's in the manual. This is simply a smaller version of this that's more compact and easier to work with. So this solar panel may have a little plastic film on it. You're going to want to take that and peel that off before you start actually taking readings from this. So taking our readings from this is fairly straightforward. We're basically going to be taking the probes from the multimeter and connecting them to the red and the black wires that are output from the solar panel here. So we'll do that right now. Just connecting the black wire to the black wire on the solar panel and the red probe to the red wire on the solar panel. And as soon as you do this, and you make a good connection. Now once you have these connections made, we're going to take the multimeter and we're going to set it to the 20V section again so that we can measure the DC voltage coming off of this. Your numbers might look a little bit different depending on the ambient light in the room at this time, but they should be somewhere around here. So what we're going to do now is we're going to take this solar panel and we're going to experiment with it in a couple different light sources. So right now, this is just the ambient light in the room. But what I'm actually going to do is take a flashlight that I have and shine it directly onto the panel. You'll notice that the light goes up, or the voltage goes up significantly. So what you can do is play around with different light sources. You can take this outside on a sunny day and you should notice the number go up even higher. And just play around and see how you can get different outputs from the solar panel and different light sources. At this point, we can move on to take the current reading from this panel, which is fairly straightforward and pretty similar to the voltage. We're just turning this now to the 20M section on the multimeter. Now this is different than when we did the wind turbine. We had it set to the 200M. This is simply just a different scale, so it moves the decimal place one place to the left so you can get a more precise reading. At this point, you could do the same thing with your different light sources. Try it with a flashlight and you'll notice that it should jump way up. Take it outside on a sunny day and you should notice it should jump way up as well. So just experiment with it, have fun, and record the highest readings that you can get in both situations. Leave those in the tables that are in your book, and then again, we'll discuss the power outputs of these towards the end of this activity. At this point, now we can move back to the wind turbine, disassembling it and making it into the hydroelectric generator that we need for the final portion of this activity. For this portion of the activity, the hydroelectric generator, we're going to start by taking your main water wheel hub here and your water wheel paddles that are included in the kit and assembling this into the full-size water wheel. So you're going to have one or two extra of these and a couple of extra of these just in case you break them. The arms can be a little bit fragile, so be careful when you're assembling these together. But all you're going to be doing is taking the slots on these and slotting them together. And you got to use a little bit of force and playing around with it to clip them together, and they'll eventually snap in place so that this arm reaches this hole here on the paddle. You'll see, just like that. So we'll do that now for the other four. Okay, now we have the full water wheel assembled. You might get some black dust on your hands. That's just a little bit of charcoal from the cutting process of these. It's nothing to worry about. Just make sure you don't touch anything that you don't want to get too dirty, but it should just wash off with water and soap, so it should be just fine. So at this point, we can set this to the side, and we're going to take our windmill and bring it back to take it apart and turn it into the water wheel and the hydroelectric generator assembly. So we'll start by removing the fan blades from the motor up top here. So you want to hold on to the motor again so that it doesn't pop out from the zip tie. And it's going to be a little bit tight, but you can pop off the fan from the shaft on the motor and set this to the side. And now we'll take the main body of the windmill apart just by taking these two slots apart and setting the small piece to this side. And what we'll do now is we'll take the water wheel and we'll press it onto the shaft of the motor in the same way that we did the fan. Now this will be pretty tight and you want it to be a pretty snug fit, but you want it to just get onto the shaft and not press too far so that it rubs against the rest of the assembly. If you do happen to have a loose fit, you can take a little piece of tape here and wrap it around the shaft of the motor, which will make it a little bit more snug when you put the water wheel onto the assembly. At this point, this is more or less ready to go, and what we'll need to do is go to a sink to finish the demonstration of this portion. So at this point, you want to take your assembly over to a sink. In this case, it's my kitchen sink. And what you want to do is you want to lay the full assembly down flat so that the breadboard and the motor are on the underside of the assembly. And you want to take something and place it onto the back of this piece of wood here so that it holds it in place. You want to somewhat position the paddles so that the end of the paddles are underneath the faucet itself. You may have to hold it in place or do some different ways of keeping it there, but as long as you can get this to lay flat enough and have it underneath the faucet, you should be able to get this to work. Now at this point, you're going to want to take your multimeter and connect it to the black and white, black and red probes that are coming off of the breadboard as we did in the windmill assembly. You want to be careful to not get the multimeter wet in this situation because it will have trouble working later on. Your goal is to try and keep all of this as dry as possible. Your paddles are going to get a little bit wet and you might splash a little bit up onto here, but it should be okay. Have some paper towels handy to wipe stuff down when you're done and everything should be just fine. At this point, you want to turn your water on fairly low. You don't want to go too fast or you can splash water all over the place. And you'll notice the water wheel will start spinning. You can turn the water up a bit and you'll notice that it should start spinning faster. Or you might have to reposition it to make sure everything's actually underneath the flow of the water coming out of the sink. I'll turn this off so that you can hear me a little bit better. But basically, at this point, you're just going to keep it spinning. See how fast you can get it without spreading water all over the place and ruining things. And take your readings on the multimeter as we did before. You're going to be doing the same thing, looking at the DC voltage and the DC current, using the 20 in the DCV setting and the 200 in the DCA setting. So you'll take your two readings and then take the highest reading that you can get and record it in the table as we did before with the wind turbine and the solar panel. At this point, you're done with the sink, so you can turn your faucet off and then dry everything off as best as you can with a paper towel, and we can take the assembly back off of the sink and go work on the power calculations to go over the different power outputs of each of these different sources. At this point, you should have all your measurements taken from your wind turbine, from your solar panel, and from your hydroelectric generator. Your table should be more or less filled out. The only thing left to do at this point is to calculate the actual power output in milliwatts from each of these different sources. It's a very simple calculation. It's all it is just the voltage times the current. And since we're using milliamps instead of amps, our output is going to be in milliwatts instead of watts. Now in this project, the outputs that you're going to get are relatively small because of the relatively small size of the generator and the solar panel in this kit. These outputs in the milliwatt scale are really not going to make a huge difference on, say, a household appliance or anything you're going to use in your everyday life. But when you think about how these scale up and how solar farms can be thousands of acres large, or these generators and these wind turbines can be hundreds of feet across, you can kind of get the scale of how big that these can get and how much power they can generate. There's solar farms, say, out in the desert in the Southwest that are generating megawatts of power, and then you look at large-scale dams like the Hoover Dam that are generating hydroelectric power for thousands of households around the surrounding area. So all of these different sources in this small scale are not very useful for everyday life. But when they're scaled up thousands of times larger, they can make a very big difference in our energy reliance. And along with the scale of these different sources, you can also look at how some of them might work better in different instances versus other ones. Think of how solar might work in Erie, Pennsylvania, where it's always cold and snowy and cloudy, and you're not getting a lot of sunlight, versus taking it to one of the southwestern states like Arizona, where it's almost always hot, sunny, and dry. You're going to get a lot more power output down there than you would up here. But you might say the opposite about, a wind turbine, where it's fairly windy up here, some places it's not as windy all the time. So you have to look at each of these applications and how they might work best in the location that they're using. Now at this point, this more or less wraps up the activity, so you can keep playing with this, go back and recreate the wind turbine, play around with the solar panel, play around with the hydroelectric generator, and more or less tinker with this as you want. If you have any questions, feel free to reach out or comment below and we'll be happy to help you with anything. Thanks for watching, we hope you enjoyed, and enjoy the rest of your activity kit.